Welcome to jain9.com. In this session, we'll discuss about arithmetic operators. Arithmetic operators. Okay. There are basically 5 arithmetic operators are there. Those are: one is addition, second one is subtraction, third one is multiplication, fourth one is division, and the fifth one is modulus operator. Modulus operators. So these are the 5 basic arithmetic operators that are available in C. There are other arithmetic operators also. There are called special arithmetic operators like increment and decrement operators. We'll discuss those operators in the upcoming sessions. Okay. So these are the operators. If you want to do any mathematical calculations like scientific or financial calculations, we have to use these arithmetic operators only. Okay. Generally, these arithmetic operators will work on numeric operands. Numeric operands. So means operand is data. Numeric operands. So these numeric operands might be real data, or that means real numbers or whole numbers. Okay. So numeric operands might be whole numbers or real numbers. So that the data types that are available for the whole numbers is, so we can use int and also char. Char data type is also available because char is a ASCII value, that is integer. So we can operate all the operations on the character data type. And also for real numbers, we have float data type. For real numbers, we have float data type. Okay. So what I am saying is, arithmetic operators will work on the numeric operands. These operators, numeric operands means there might be a whole numbers or real numbers. For the whole numbers in the C language, we have int and char data types, and for the real number we have float data types. And also we can classify these operators as binary and also unary operators. Okay. So if you see here, addition operator will work as unary and also binary operator. Unary and also we will discuss, we'll try to write the programs here also. Unary and binary operators. We'll try to understand here itself. And subtraction is also acts as unary and binary operator. And these multiplication, division and modulus operators, these all are binary operators only. These are binary operators only. So we know that binary operator means each operator will work on 2 operands. Unary operator means it works on only 1 operand. Binary operators. Okay. These all 3 are binary operators. Okay. Now we will see first of all unary operators, how it will work. Then we will see the binary operators. So if each operator is working as a binary operator, there are 3 types of possible combinations are available here. Like both operands might be real numbers, or both operators might be whole numbers, or is a combination of real and floating point number. That means integers and floats. Okay. And what will be the result? Each operator will return, every operator will return the result here. Every arithmetic operator will return the result here. Every arithmetic operator operator, whether you catch it or not. And that means you save the result for the further calculations as per your requirements, or you may not. That is up to us. But every arithmetic operator will return the result after calculations. Will return the result. So we know that each operator is a token. It is a character. Okay, it is a character, special character or symbol we can say here. And we know we have discussed in the previous session what are operators. Either special characters or symbols. Okay, those are tokens that are validated by the compiler. So here, for each operator, it operates on the operands, whether it may be one operand or two operand, depending upon number of operands. And and for, let us suppose, if it works as a binary operator, there is a equivalent assembly. There is equivalent assembly code instruction for each and every operator. If, let us suppose, if it is a plus operator, there is a add instruction in the assembly level language, or according to x05 or x06 processors family. So we can use the instruction set according to, they will be implemented like that. For each operator, there is an instruction for in the assembly language for according to underlying processor architecture. Okay, for this we can say x86 or 86 family, 85 or 86 family, there is a subtraction, there is a sub instruction, there is a mul multiplication instruction, there is a div instruction. There is no modulus instruction for the 86 or 85 family, but after division there is a remainder that will be stored in a separate, like dx registers apart from the accumulator. In the accumulator or in any source registers, the data resultant will be saved, and the remainder will be saved in some, let us suppose, like in a temporary register like dx registers. So the remainder can be taken as a modulus, means the result will be saved. We can get the result from the modulus operator as a from the ds registers, like that. Okay, so each operator is an inbuilt operator. We can understand these are the basic operators that can be implemented directly with the help of the, means with reference to the assembly level language also. Okay, and also this operator can be expressed like this also. Let us suppose a modulus operator can be act as a, let us suppose, if you take the formula here, let us suppose a plus means modulus b equal to, it can be can write the expression to achieve this also, a divided by b. Okay, sorry, b into a divided by b. Okay, so this is the expression. From this expression also we can achieve the modulus operator. Okay, and this is the floor division, or you can say directly it is integer division, because in the C language, integer division, if both are integers, if there is any fractional part also, it will be truncated. We will see right now. So how it works as while working with binary operators as integer mode arithmetic. In the integer mode arithmetic, we will see one by one. But as of now, so with this formula also we can achieve it. But directly there is a, if you operate modulus operator directly also, there is only division arithmetic will be executed in the underlying assembly code architecture, and the remainder will be stored in the dx registers. So the remainder will be available. Okay, so from this we can get the remainder. So that remainder we can use it for the further calculations, or you take the printout, you take data, means a result in the console also. Okay, we'll see one by one here. Let us suppose we'll take as a, first of all we'll explain one by one. Let us suppose take addition operator. So it will be act as a unary and binary operator. So take this. Let us suppose this is, I am taking as a unary operator. So plus, let us suppose 2. Okay, semicolon. This is semicolon. This is a valid statement here. We try to compile it, save it, and just compile it. Okay. So go to desktop and gcc demo.c. Okay, it is perfectly compiled. There are no errors because this is a valid expression. Okay, this is a valid expression. This is called here it is called sign operator. Okay, positive sign operator. You can also use so subtraction as a negative sign operator also. So let us suppose if it is -2. Okay, so this is a valid. This is a valid expression, and it is a valid statement, and so it will be executed without any errors. We will try to execute this also. Yeah. Yes, it is executed, and we run that. We ran the exe file also. So there are no errors, runtime or compile time errors. So these are unary operators. Okay, these are unary operators. Unary operators. Unary operators. This is unary operator. Plus is unary operator, and this is also unary operator according to expression. According to whatever the expression you are writing, it will compiler will check whether it is valid expression or not, and then it will be compiled like that. Okay, now addition and subtraction will act as a binary operators also. That means it takes the two operands and will calculate it and will get the result resultant to you. So whether you catch it or not, that is up to us. We will see right now. Let us suppose I'm taking as a addition as a binary operator. Now let us suppose 2 plus 2. Okay, 2 plus 2 semicolon. Okay, this is a valid expression. This is a valid expression. Here it is act as it is binary operator. Binary operator. Okay, this is a binary operator right now. It has a left operand and right operand. Both are integers only. We will see what is the means according to mode. How what will be the result? What will be the result that operator will give? We will check it right now. But this is a valid expression. You try to understand. This is a valid expression. Whether you each operator will return the result after calculating the after calculating the operation according to, let us suppose this is addition operation. Okay, left operand and right operand will be added and resultant will give to you. That will be stored in the, like, let us suppose if it is x5 family, that is saved in the accumulator, or if it is x6 family, so that will be stored in the source operand location, source operand memory location. Okay, so according to family it will be decided, but a resultant will be saved. Whether you use that resultant result or not, that is up to us. Let us suppose I would like to take the result, but not in a named memory location like variables. We will be discussed variables and data types in the upcoming sessions after completing operators and separators. But as of now, you try to understand each operator will return the result, and whether you catch the result, you use the result, you do means for the further calculations as per our requirements. If we have any requirement, we can catch the result. But as of now, we don't have any requirement to save that result that is given by the addition operator. But I would like to print it. That means the result will be taken, and also it will be passed to the, it will be sent to the console memory, like that. We will do like that with the help of the printf statement. Okay, so let us suppose take one printf statement, printf printf, and let us suppose you type like this result %d, because so if both are integers, the result is also integer. Okay, if both operands are integers, we can say this is called integer mode arithmetic. Let us suppose operand numeric, and so let us suppose int, if suppose one is left operand is integer plus right operand is also integer. Okay, then the result is also always integer. Result is always integer. Result is always integer. You try to understand here. If both operands are integers, then the result is always integer for all the arithmetic operations. You have to understand for the division also, if there is any fractional part also, it will be truncated. Only integer value will be returned as a result. You try to understand. Now let us suppose, okay, the format specifiers will be explained in the upcoming sessions, but as of now we are explaining tokens only. You try to understand the tokens, then we'll try to explore one by one, like variables, data types and variables, and format specifiers. All will be explained in the upcoming sessions. No need to worry at this point of time, but we have to understand what are the basic operators, and also what are the basic arithmetic operators, and what are the remaining operators that are available in the C language. Let us suppose increment and decrement operators are not available in the Python. Okay, not required actually. So we can implement with the help of the simple one adding to the one value to the whatever the source that is. Okay, whatever the value that is, it will be very easy. But in the C language, they have developed as a special arithmetic operators will be discussed in the upcoming sessions. And there are the expressions. So maybe freshers may be a little bit confused while working with increment and decrement operators at the starting point, but later it will be easy to understand, easy to work with. We'll discuss all these operators, those operators in the upcoming sessions. But as of now, you try to understand. Let us suppose I would like to take not only this expression. I want a separate calculation. If you want separate calculations also, you do it. Otherwise, I would like to take the same data. Okay, let us suppose 2 plus 2. Okay, so give space for the readability and understandability. It will be very easy to understand it. So right now this statement will be executed. This is the separate statement and this is a separate statement. This calculation is different and this calculation is different. Okay, or otherwise if you want to comment here, you can comment it, or if you want to take another expression also, you can take it. Let us suppose 2 plus 3. Now would like to take according to this expression, the value will be the output value will be the 5. I would like to take that result but not saved in the named memory locations like variables, but just I would like to pass this result to the console memory. So in the console memory we can see the output right now, so with the help of the printf statement. So right now I would like to execute this. You can understand it. So gcc space demo.c a.exe. So answer is 5. Okay, we got the result. We have not saved it for the further calculations, but on that statement we can just pass the result to the console. So on the console we can display the output like that. Okay, fine. Now you take the remaining operators also. We have 5 operators, right? You try to take it. Let us suppose would like to print all the operators right now. So all are integers. Let us suppose take this combination like integer plus integer. We'll see what will be the output. So for the division operator, we have to understand that if there is any fractional part, it will be truncated. That's it. Those things we have to consider it. That's it. So /n. Okay. And just you try to copy this and paste it. That will be good. 2 minus 3. Sorry, 2 minus 3. And okay, multiply it and divide it, and also modulus operator. Do the modulus operation like this. Okay, so save it and try to run it. gcc demo.c. okay, a.exe. See here. So addition is 5, subtraction is -1, multiplication is 6, 2 into 3 6, and so division is 0 because there is a fractional number but it is truncated because we told, right? So integer, okay, if both are integers, in the division part all the result will be only integer. If there is any fractional part, it will be truncated. If there is no fractional part, that is fine. If there is fractional part, it will be truncated. If you want to catch that floating fraction also, you have to convert the literal to the floating point number, or otherwise typecast it. Okay, we can do in both ways. Okay, we'll try to check it now, and we will get the remainder also, because 2 by 3 is the remainder is 2 only. Okay, fine. Now, so if you want to catch it, if you want to catch this fractional part also, you can do it in 2 ways. We can do it in 2 ways. It will be a combination of, like, we can say floating point number and also other combinations. We'll try to see those combinations so that we can understand it. Okay, now let us suppose take this and we throw the remaining combination, that is integer, floating and float. Okay, so both operands are float. Result is always float. See here, there will be no fractional part is coming. Okay, there no fractional part. If you don't want to lose the data, definitely we have to convert. Okay, either operand, or otherwise you convert this operand as a float, means using dots, or otherwise if it is in a variable, then use the typecasting. Okay, use typecasting, you can get it. Okay, we'll see right now. If you do this and just execute right now, you will get the fractional part also. Okay, and a.exe. See here, the fractional part is coming here. Okay, you cannot means you no need to lose the data if you do typecasting. Okay, I will explain typecasting in the in this session only, because in the upcoming sessions while explaining the typecasting operator. But as of now, if you don't want to lose the data, and if it is in a, if the data is in the variables, okay, if the data is in the variables, you try to typecast it, so you cannot get the means you no need to lose the data. Okay, like this also you can get it. Now coming to, okay, combination, floating and floating combinations, float plus float combinations. Okay, printf, and yeah, and so remainder will work only for integers only, not on floating point numbers. Okay, you try to delete this and okay, execute this. Sorry, cls and compile right now and execute this. So this is about fractional part numbers. Okay, you try to take one printf. Okay, try to comment this, or otherwise we would like to give the single line, and then there is a one more printf statement like this, and okay, you try to keep this inside this /n. Fine. Now compile it. cls gcc demo.c. Yeah. Okay. /n. Save it. cls gcc demo.c. Okay, we can understand. So if both are okay, if both are floating point operands, definitely the result is always float. Okay, you try to understand here. And so here we can take, this is a operator, or you can say any operator that is as simple as possible, any arithmetic operator. Fine. Then and if there is a, okay, there is other combination right now. So if it is one operand is integer and one operand is float, the result is always float. You try to understand the third combination, that is called mixed mode arithmetic. You can understand right now. So if one operand is integer, okay, either left or right, always the result is always float. Okay, whether it is left operand or right operand, the result is always float. You try to take this also, and copy this, paste it here. And if it is int, okay, this is one combination, whether it is left operand or right operand, the result is always float. Okay, the result is always float. Float and int. Okay, the result is always float. You can try to understand here. So 2, it is integer, and this is floating point number. Always result is float only. And let us suppose this is floating point number and this is integer. Always result is floating point number. You take this and you take this like this, and you can take this as a integer. Okay, now to 0.0/3. Okay, the result is always float here. You compile it. gcc demo.c, and yeah, can understand whether it is, this is called mixed mode arithmetic. Okay, whether one operand is integer or one operand is integer and one operand is float. So the arithmetic operators, all the arithmetic operators will return the float value only. Okay, you can observe the result itself. Okay, fine. So this is about unary operators. Means all arithmetic operators, whether it is in unary mode or binary mode. And there is a different combinations like integer mode arithmetic, or floating mode arithmetic, or mixed mode arithmetics. And also we can we told, right, so characters are only it is a ASCII representation. Finally it is saved as integer itself. So all the arithmetic operands, all the arithmetic operators, all are valid for the characters also. All are valid for the characters also. You can understand here. Let us suppose I would like to take the printf. Okay, char arithmetic, char, all are valid operations only. Char arithmetic here. Would like to take it. Let us suppose printf, printf. Let us suppose take a plus b. Okay, and yeah, we take percentage d. Okay, let us suppose a plus b equal to percentage d. If it is percentage d, okay, then because the result is integer, you can take a is 97 in the ASCII and b is 98. It is ASCII integer. Okay, b. Now you can see the result here. You can see the result here. Save it and compile it. CLS GCC demo.c. Okay, see here a plus b is 195 because 97 plus 98, it is 195. So all the character arithmetic is perfectly valid here, because underlying these are integers itself. So so definitely all the character arithmetic are valid here. You can try remaining operators also. You can try it also. Okay, so let us suppose if you want to take minus and multiplication, okay, and also division, okay, the result will be, both are integers, right? So the result will be only integer, and if there is any fractional part, it will be truncated, and also modulus operator. All are valid here. All are valid here. Try to understand. All are valid here. Okay. Char arithmetic. I can type here. Char arithmetic. Compile it. GCC demo.c. Yeah. So we have not given a new line here. Yes. New line. New line. New line. New line. A new line. Okay. So clear the screen. GCC demo.c. Okay, yeah. See here, 97 plus 98, 195. This is 97 minus 98 minus 1, and multiplication is 9506. Addition, sorry, this is not updated. Okay, fine. So a minus b. Okay, and division, and also modular division. Okay, all are perfectly valid. You can understand here. CLS demo.c. Okay, see here, a modulus b. Okay, clear the screen. GCC demo.c. So we will see here, addition is 195, subtraction is minus 1, multiplication is 9506. So division is 0 because fractional part is truncated here. 97 by 98, there is a fractional part, but it is truncated because it is integer division, and the remainder is 97 itself. Okay, 97 by 98, that is 97 is the remainder, like this. Okay, so this is about the arithmetic operators in the C language.